All right, good morning. Sorry it's a little dark. Baby woke me up a little earlier than normal, so we're getting started a little earlier than normal. Let's jump into it. All right, Advent Code Day 5. Board your plane, discover a new problem, you dropped your boarding pass, you aren't sure which sheet is yours, so all the flight attendants are busy. You write a quick program to use your phone's camera to scan all of the nearby boarding passes, which is your puzzle input. Perhaps you can find your seat through process of elimination. Instead of zones or groups, this airline uses a binary space partitioning, I don't know what that is, to seat people. A seat might be specified like FB, FFRLR, where F means front, B means back, L means left, R means right. The first 7 characters will either be F or B. These specify exactly one of the 128 rows on the plane, numbered 0 through 127. Each letter tells you which half of a region the given seat is in. Start with the whole list of rows. The first letter indicates whether the seat is in the front 0 through 63 or the back 64 through 127. Okay, the next letter indicates which half of that region the seat is in, and so on until you're left with exactly one row. For example, consider just the first 7 characters. Okay, start by considering the whole range, 0 through 127. F means take the lower half, keeping it 0 through 63. 127 divided by 2, it rounds down. Okay, good to know. Let's just integer division. Upper half, 32. Is that still 3? 63 divided by 2 is 31. So it isn't. F is floor, B is seal. Okay, so rounding up, rounding down. Glad I checked that. F means take the lower half, keeping 32 through 47. Okay, so and so on the final F keeps the lower of the 2, row 44. The last 3 characters will either be L or R. These specify exactly one of 8 columns of seats, numbered 0 through 7, the same process. Okay. So decoding this reveals that this is the seat row 44. So I'm going to write my program to use this as some test input. Because I actually wanted to code that to start with. As a unique seat ID, multiply the row by 8. Okay, then add the column and this exponent, blah, blah, 3 for 7. Here's some other boarding passes. As a sanity check, look through your list of boarding passes. What is the highest seat ID on your boarding pass? Does it actually... Okay, I'm gonna try to write something that that can figure this guy out first, and then we'll go from there. Okay, so I don't even know what to call these. Directions. I actually want to convert these into array because I know I'm gonna have to like split this later, but I know how long it is, right? It's right here. I know how long it is, so I want an array so I can index directly into it, and it's 0 through 127 if I'm not mistaken. Yeah, 0 through 127. Okay, so let's do that. So min equals 0, max equals 127. Okay, and then so let's say for direction, well, yeah, 0 through, let's see, 0, 1, 2, 3, 4, 5, 6, 0 through 6. 0 through 6. Okay, so in this case, we're going to say the direction equals directions sub I. Okay, so we're going to get, this will get us all of those, and then we're going to say if D equals F, then we're going, which it does, they're going to say we already know we have to round up. We determined that, and then it is max minus min plus min, right? So, oh crap. Okay, so let's do this. And then convert that to an int. Okay, and then min equals that. Did I do that right? Yeah, so convert them to doubles, divide them, round down or up for F. F is lower half. Okay, so actually for this, we actually don't even we don't even need to do that. What we need to do, oh, and I don't know how I just like walked right past this. So I'm going to take the distance between these two and then divide it by 2 and then add that to the minimum. And then else if, well, the input should be validated, so I don't need to do the if. Otherwise, max equals max minus min divide, this one's going to be a problem, divide by 2. I think that's what we want. I think this one's going to be a problem because I think we're actually supposed to do a round up instead of round down. Let's see really quick though, and make sure that I'm thinking about this right. But yeah, I think we need to round up and round down, which is where the doubles came in, because integer division naturally rounds down. Okay, 0 through 127, it's an F. So now we are looking for 63 through 127. I'm thinking about it backwards. Glad we did this. Max equals max minus. See, this is why you validate. And I honestly, I don't know why. I think it's more readable to do it this way. I don't know why I did it that way. I always like using the debugger in these kind of situations so I can see the real data coming through. 0 through 64, and it's supposed to be 0 through 63. Okay, so which is what we expected, right? This needs to be rounded up. So let's do that really quick. So convert these to doubles, double, and then we're going to seal, which is ceiling, for those of you that are new, ceiling going up, floor going down, and then convert it back to an integer. Okay, 0 through 63, perfect. Okay, and then next loop is going to take us to 31 through 63. Wait a second, let's see. 31 through 63, that's not what I expected. do some rounding. So 0 through 63 is 63. Divided by 2 is 31. Oh, and I need to round up. Do I always need to round up? Wait, how did I do this wrong before? 127 divided by 2, 63. And then 63 divided by 2 needs to be rounded up. And then that is 31 spots remaining. 63 minus 16, 47. Okay, so we always round up. Again, don't know how I missed that, but I did. And I put the seal on the wrong spot. Let's fix it. Actually, I don't know why I'm also doing this, because I don't need to. So I can do a double here, and then seal, and then hit. Okay. Okay. 0 through 63. I'm going to shoot this window so I can see it. 0 through 63. Next. 32 through 63. Next. 32 through 47. Next. 40 through 47. Next. 44 through 47. Next. And then 44 through 45. Next. And then 44 through 44. Okay, so that's the first part of our solution. Okay. So since we do this, it's a programming challenge. Keep it hacky. Okay, and then so we're going to do, we're going to make a function. This is row. From a string, it returns an integer. So it goes this, and then it returns min or max. They should be the same. Oh, yep. So let's do this. Let's change this back here. Get our array directions. Okay. Okay, so that will get us min max for the, so that row equals row for directions. Let column equals, and we're going to do basically the same function. Column equals column for directions. Okay, the difference is though, column is, excuse me, the column is, what does it talk about the column? Upper half, lower half. Start by considering the whole range 0 through 7. Okay, so columns are only 0 through 7, and it is only 3 digits. It's the last 3 characters, which means that it starts as 0, 1, 2, 3, 4, 5, 6. So it is 6 plus I. Okay, and then instead of F and D, it is L and R. Okay, so we should have okay. And then we should be able to print row value, column value. Okay. Okay. Input. Let's try that one more time. Okay, so the result is 44.6. Keeps the upper of the two. Oh. The final F keeps the lower of the two. Okay, so this part isn't right. Let's see, we want directions sub 6 equals F, and then return min, otherwise return max. In this case, I'm a little concerned because they were the same, so I think I might have done something wrong there. Just keeping a mental note for that for later. In this case, equals lower, then return the min, otherwise return the max. Yeah, I'm a little concerned. I think this came out wrong. 44 and 6. Yeah. I'm a little concerned about that. Last 3 characters. So let's go through this. So this one, the last step didn't come out right, and so I'm kind of concerned about that one. And then the second part didn't come out right at all. That's not necessary. Okay, so 0. I guess I can put just the right part down here. 0 through 63, 32 through 47, 40 through 47. Oh, I think the breakpoint's actually stopping in this case. Let's try that again. 0. I'm not inside the loop. Good morning. 0 through 127, 0 through 63, 32 through 63, 32 through 47, 40 through 47, 44 through 47. Okay, so the last one is 44 through 47, which is 3. 3 divided by 2 is 1.5. We round up. So, am I wrong? Did I just read it wrong the last time? 44 through 45. Oh, the final F keeps the. Oh, the final F keeps the lower of the 2. Dumb. Okay, so what we actually want here is this goes through 5, this keeps the lower of the 2, this goes through 2 and keeps the upper lower of the 2. I think that should be right. 44 and 6. Still wrong. Okay, let's figure out what's wrong with this one then. But I think I understand this one correctly then. Just to be consistent, let's change this to 9. Okay, what am I doing wrong down here then? 0 through 7. So 0 through 7. Okay. Okay. Takes them in 4 through 7. Okay. 6 through 7. Do I have it backwards or something? R takes the upper half. R takes the upper half. 44 through 5. No. Wait. So you see, they multiply the row. Okay, 44 in column 5. Okay, there we go. So I think I just had that backwards. Every seat also has a unique seat ID. Multiply the row by 8. Okay. Then add the column to this. So 44 times 8 plus 5. So then let ID equals row value times 8 plus column value. Okay. Row value. So the end result should be 44, 5, 357. Okay, and it's giving us multiple boarding passes, so it would be like a little foolish not to just at least run them through and make sure that it's working for those. 77, 5, oh crap. Did I have, so the column's wrong again. We're back to wrong column. 14, 4, 116. Yeah, column's wrong on all these. Okay. What am I doing wrong on column? Okay, on column. The first direction is F. That's not right. This is supposed to be 7. And then is this supposed to be left? I just got lucky on the first one by swapping it. The actual problem was the index. 77, 567. Oh my gosh. It's amazing how often I just get lucky with some of these inputs and it covers a bug, which is why you need to test a broad range of inputs. 102, 4, 820, and then the original, which was this. Which was supposed to be 44, 44, 5, 357. Okay, let's get our puzzle input then. We're going to validate all of these. What is, okay, so what am I supposed to be submitting? I didn't even read that part. Okay. What is the highest seat ID on your boarding pass? Is that it? That's just what I'm supposed to put in. What's the highest seat ID? Okay. For input array equals, sorry, let input array equals input dot split on the new line character, our favorite function for input in input array. We do this, except for I actually don't need that in here. Our largest ID equals, we'll start at 0, I guess. If ID is greater than largest ID equals ID. Okay, so keep track of the biggest thing, and then we're gonna just print largest ID here at the end. Yeah, as a string. I hate substring so much. It makes my life hard. It's for an optimization. I don't love it. Okay, 911, it says is the biggest ID. Let's see if that's right. That was right. Cool, that's what we get for validating. The fastest seatbelt sign, fasten seatbelt sign, finds your seat is completely full flight, so your seat should be missing boarding pass on your list. However, there's a catch. Some of the seats at the very front and back of the plane don't exist on this aircraft, so they'll be missing from your list as well. Your seat wasn't at the very front or back though. The seats with IDs +1 and -1 from your seats will be in the list. Okay, so now what we want to do is we want to do the same thing, but we want to keep track of all the IDs, and then we probably want to go, and then we want to go through and find out where there's a gap. Okay, that should actually be super easy. So what we want is we're going to do literally this again, but we're going to do, these are inputs, and this is going to be an array of integers, or this is, sorry, seat IDs. And then we're going to do seat IDs.append. What the heck was that autocomplete? Can I not append at the end of an array? Holy cow, what is happening? Am I calling it the wrong thing? These are the types of questions. Oh, it's because I haven't initialized it, and so autocomplete's confused. Yes? There we go. Okay, and then what we're going to do is we're going to do CIDs.sort by less than, and then we're going to print CIDs. I want to make sure that this actually looks right, and I can probably scroll through. Ooh, never mind. That is sorted correctly. Okay, so then what we're going to do is we're going to do for I in 0 ... less than input array .count. We're going to say current equals input array sub I, so we're going to get the current index. Next equals input array of I plus 1, and then if current plus 1 does not equal next, print I. Is that what I want? I think so. And then break. I think that's what I want. I actually don't know if you can initialize an int from a substring, can you? Is it okay with that? These are all going to be integers. What am I doing? Oh, seat IDs. Seat IDs. Oh, that was close. Well, yeah. Seat IDs, not input array. That's why this is being weird. 2 lessons learned, don't code while sleepy, and use a language that is strongly typed. 532, and then we can actually look at our list and verify that that makes sense. 531, 530. Oh, it's, dang it, I printed index. I don't want that. We want to print current. I'm not going to count through this one. 628. Okay, that's actually what we want. 628, 626, 627, 628. 629 is our empty seat. 629. Submit. Yay. Okay. So let's talk about the solutions here really quick. Okay, so the problem's pretty straightforward except for this binary space partitioning thing. I didn't know what that was, but then as soon as I read the problem, I realized it's just doing binary search, which means you take a list, you cut it in half, and then you see if the thing you're looking for is in the left or the right side, and then you search that side, and you just keep splitting and splitting until you land on the right thing. And in this case, you can get through 128 items in 6 jumps, I think is what we said. 7 jumps, you can get through 127 characters, which is pretty good. It's a very fast search. So, obviously in this case, it would just make more sense to just write the row number, but you get the idea. If you had a list of something else that wasn't just numbers in order, then this is super fast. So anyway, we'll do another episode on binary search later. Okay, so basically the hard part here was understanding the parameters of how they wanted you to search. Because the thing is if you divide 0 through 127, so you have 127, and you divide it by 2, it's 63.5. And so you can't have the decimal place since these are integers. And so first question was, do you round up or do you round down? And that's what I was testing for with this at the very beginning, was, do I round up or do I round down? Turns out they want you to round up. Okay, that's fine. So we get the round up, round down figured out. And then after that, it's just a matter of running through the numbers. So the weird thing to try to wrap your hand around is like, oh, search all of them, split it in half, and then search this half. That's kind of weird, because then it's like, oh, well, do I have to try to like split an array, or how do I keep track of this? And it's like, no, you're just keeping track of the two numbers. And so what I was looking for, and this is what I try to pay attention to for these kind of problems, is 0 through 127. And then on the next line, what's the part that's consistent? The 0 stayed the same, though the 127 changed to a 63. So 127 minus 63 is 64. So like we already knew that if you divide it in half, it's 63.5. So if you round up and subtract 127 or 64 from 127, you get 63. So then it's like, oh, okay, I'm just keeping track of a min and max here. And then you do the same thing, right? So on the next row, 63 stays the same, 0 through 32. So if you're new to these kind of weird programming questions, like, start looking for the patterns between each step. Now, Advent of Code's great. They give you lots of steps, and they, especially on weird ones like this, they'll give you multiple inputs to help you validate. So first things first, look for the patterns if you're not sure where to start. In this case, each step is only keeping track of two numbers. So to me, I was like, ding, 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 min and a max. And then it narrows down to the last thing. I got this step wrong. I did, again, read carefully, right? The final F keeps the lower of the two. Now, because I'm always rounding up, I'm pretty sure it would always just pick the highest number if I just kept doing the same algorithm on the last one. So that's why the very last digit of the input I did differently. I could be wrong there, but I'm pretty sure just from playing with it and looking at it, that's what would have happened. So yeah, read the thing carefully. And if there's something that's like distinctly different, so in this case, it stopped keeping track of two numbers and it's giving you a different set of instructions. It's saying the final F keeps the lower of the two rows, 44. Rather than talking about upper half, lower half, that should also be a red flag in your mind, saying like, oh, okay, like there's something going on here, like I should pay attention. The second half of the problem is literally the same problem, and if I was going to like actually try to code up like a binary search thing, I would probably make this reusable so I could use the same thing for both halves, but it's a coding problem, so I didn't want to think about it. I just copied and pasted it, changed the F and the L. That's another common problem, is people are copying and pasting between stuff and they don't update the variables that are important. So like the F and the range that you're going through. So in this case, I got that part wrong. I thought it was supposed to be 6 because this one ends on 6, which is dumb. It's supposed to be 7 because it's the next one. The last one would have been an F or a B. Okay, so then, but then this part, getting the unique ID, this is a nice way to like validate that your input's right, again, but like that is not hard. That's literally just row times 8 plus column. So there's no fancy algorithm there. And then the last thing, so keeping track of the highest seat ID, I went through, and as I was doing these, I just kept track of the largest. The other thing that you could have done is just done part 2, right? Put all of the inputs into an array and just sort it and look at the last item. Like that's a totally valid way to do that as well. And then you'd already have a sorted array set up for part 2. So honestly, if this was something that, I was writing a real program that was going to do something like this, and it was always going to do these two parts connected together, just to keep it simple, I might actually just do that in general. Just say like, okay, I'm going to build up an array of all the IDs, sort them, since I have to sort them anyway. Look for the biggest one and also look for the missing one. So, but in this case, because I already had it solved for one part, and I like to keep the parts separate, didn't bother with anything like that. Okay, and then there's nothing special after that. So yeah, that's the solution for day 5. Hopefully you guys found that valuable. Again, we're going to be doing this every single day. We're going to learn something every single day. In this case, I can't wait to post my solution and see what you guys tell me I did wrong or could have done better, because I love seeing new tips and tricks, especially when it comes to this kind of stuff. There's always going to be something I'm sure there's actually probably a way with the standard library that I could have actually just binary searched this and gotten the right answer with much less code. I just don't know the answer off the top of my head. So yeah, I'd love to learn some stuff. If you got something to teach me, leave it in the comments below. If you're enjoying these videos, make sure you like and subscribe, because it helps us get more visibility, helps more people find the videos, and hopefully helps more people learn from this Advent of Code challenge. All right, thanks for watching. We'll catch you on the next one.